This is ODME channel.
I have been assigned to deliver a talk on climate change. So climate change I will tell because I told you meteorology, how meteorology is defined. Actually meteorology is a pseudoscience. We believe that meteorology is from geography, but pseudoscience we call it because this is the application of physics and mathematics are applied in meteorology. Meteorology is a combination of four branches that we call climatology, synoptic meteorology, thermodynamics, dynamic meteorology. That dynamic meteorology in other way we are calling numerical weather prediction. In the earlier days we are giving the weather forecast based on climatology and synoptic meteorology. Synoptic meteorology means that is a simulation type. We prepare the weather charts from the surface to the upper level up to 12 kilometer height. So that weather charts during a cyclone or during low pressure or during heat wave, during cold wave, during any thunder squall or any adverse weather, we draw the isobars that is with what we call low pressure circulation, high pressure, and the streamline is also to river level to get the cyclonic circulation trap. So we understand that these are the features which can cause the bad weathers. So similar type of situation when it occur, then you understand situation similar type may occur, but it's not always true. But most of the time it happens. So that's why synoptic meteorology was very important before 1990. You can say before 2000. Prior to 2000 in India, we are not applying numerical weather prediction. So and climatology there because we know that in different seasons what type of weathers occur, like a pre-monsoon, monsoon, then your post-monsoon and winter season, because winter season called January, February, generally fog and western disturbance in northwest India, in our part fog and cold wave. And pre-monsoon season generally we experience about the heat waves, then a thunder squall activity. Rarely the cyclones come to the in the Bay of Bengal or Arabian Sea. But post-monsoon season call it the rainy season, that is the mostly the 80% rain we receive during the rainy season, that heavy rainfall and the flood is there. But post-monsoon season with another way we call it cyclone season, mostly the devastating cyclones occur in the post-monsoon season.
Good afternoon. You have these days noticed that the summers are getting hot. When I was your age, that is about 50 years ago, I'm 62. 50 years ago, the summers in Odisha were not very hot. The winters were cooler. So now I can say, because now I have observed over a period of 50 years, so it's becoming interesting, is it? Good, it should. So over a period of 50 years, we have noted a climate change here in Odisha. Now you got all the scientific information that form the background for a discussion like climate change. But I'll come down to the very basics and I'll explain quite a few interesting things. I know it's getting late, but do give me a little time. Now, I want to start with you. I want you to understand what is climate change, what are the effects of climate change, and what can you do. These effects of climate change could be very dangerous for humanity. And if you are aware of the various issues of climate change and the adverse effects of climate change, you can save humanity. That is, you can save yourselves, the society, and the world, because you are important. So, here, allow me to mention the concept of essence. I'm starting with you. Professor explained the science, and now I'm coming to you. All right, so I'm starting with you. Are you aware of this concept of essence? You know what is essence? Sara, gist. Flower essence, perfume. All right, you understand that? So, will you be surprised if I say that you are the essence of the entire material universe? Will you be surprised? You are the essence, you are that important. And why do I say that? And what is material universe? This is planet Earth. Planet Earth is a part of the solar system. Yes? Solar system is a part of the Milky Way galaxy. Yes? Yes, sir. And then Milky Way is a part of, in the past we used to use the word nebula. We are not using that anymore. we used to say that Milky Way galaxy is a part of Andromeda nebula. Yes? But nebula these days, we are not using the term, we are just saying big galaxy. And then that is a part of the universe. Yes? So now I'll take you back to Chandogya Upanishad, as described now Upanishad, alright? Very interesting. Now how is it related to science? I know some of you are very worried now. How is it related to science? Alright? Now, the concept of essence in Chandogya Upanishad. That is, essence of the entire material universe is planet Earth. Can you hear me? Am I audible? Alright. Essence of the entire material universe is planet Earth. Essence of planet Earth is water. Essence of water is plant. Listen to me this carefully and remember this all your life. And essence of plant is water. Essence of water is, I'm getting confused. Essence of the planet Earth is water. Essence of water is plant. Essence of plant is human being. Essence of human being is speech. So how you speak is your essence. Remember that. Is that clear? So learn to communicate well. I'm taking like a class. Professor explained the science part. I'm now teaching you. Alright? So essence of a human being is speech. And essence of speech, here it becomes theology. Theology, you understand? Religion. Teachings of religion. Alright? Essence of speech is Rigveda. Essence of Rigveda is Samaveda. We don't have to go into that. But this is what it says. And essence of Samaveda is Chandogya Upanishad. Essence of Chandogya Upanishad is Om. Alright, I won't go into the spiritual side. But what I want to tell you is that Chandogya Upanishad is beautiful because it explains that you are important. You are the essence of the entire material universe. Because this climate is changing, the world climate is changing, it will have many adverse effects. How are we going to protect ourselves? Who will protect us? We ourselves can protect us. Yes? Is there anybody else to protect us? So you must realize that you are important. You are very important. Yes? Do you realize that? Never underestimate yourself. Is that clear? There is genius in all of you. Alright, so in that connection I'll tell you again a story from Chandogya Upanishad. And then I'll come to climate change. This is the story of a father, Uddalaka, and his son Swetaketu. Swetaketu goes to Gurukula. Like you have come to a school to study. Father Uddalaka sent his son Swetaketu to a great teacher for higher education. There he studied for 12 years and then he came back. Father saw the son Swetaketu rather conceited. You understand what is conceited? Arrogant. At times you become arrogant when you are with your grandmother who does not know how to play with the, smartphone. You are teaching her how to play with the smartphone. You become very arrogant because she doesn't know anything. Isn't it? Yes or no? Some of you do become arrogant because you have acquired a little skill which your grandmother doesn't have. Yes? That's not good. That is not nice. Alright? Because they are much older, the skills were not there in those days. You have them, but that need not make you arrogant. Alright, so when he saw his son rather arrogant, he told him a series of 7 stories. Now I'll tell you the last story. And keep this story in your mind all your life. Alright? Now I am telling you, 50 years down the track you tell others. Yes? Yes, sir. And the story is, father says, son, do you see that large banyan tree? At a huge distance, there's a huge banyan tree. Yes, father, I see the large banyan tree. Son, could you fetch me a fruit from that banyan tree? Son goes and fetches a fruit from the banyan tree. And you know the fruit of a banyan tree only is the size of a berry. Tiny, small. Then father points out, son, See, for the size of the huge tree, the fruit is so small. This tiny fruit is the essence of this huge tree. Yes? Cut open the fruit, son, father asks. Son cuts open the fruit, and then father asks, what do you see, son? I see many tiny seeds, father. All right? See, for the size of this fruit, the seeds are so tiny. Cut open a seed, son. Son cuts open the seed. And then father asks, what do you see? I see nothing. Father says that nothing is the essence, my son. You see, you cut open a tiny seed, of course you see nothing. But that nothing is the essence, and that in Sanskrit is Tattvamasi. Tattvamasi you might have heard, some of you might have heard if you have taken interest in Sanskrit. And that in English is you are that. You are that means what? You are that essence. So for us, you are the younger generation, we are the older people. You are the future, you are the essence. And that is the reason why we are passing down this knowledge, information to you, so that you enrich yourselves and acquire the skills to save the planet Earth. So do you realize how important you are? Yes or no?
Yes, sir.
You are all important. Yes or no?
Yes, sir.
All right. Now we'll go to climate change. So once you become aware of the various issues that Professor pointed out, I'll explain some of them. Then think over it. I'll go, and I have been asked to give a talk on the effects of climate change on the earth and the oceans, which you can also call the land and the sea. What are the effects of climate change? I'll start with the sea level rise. You have seen the sea, some of you. I would assume that all of you have been to Puri. You have seen the sea. Yes?
Yes, sir.
The level of the sea, we call it sea level. Yes? In geology, we use a term called strand line, so I will not go into geology. I'll make it simple. The sea level is rising slowly. For the last 18,000 years, it is rising. Yes? Now you take it from me. For the last 18,000 years, sea level has been rising. And it has risen by 130 meters. 130 meters. In feet, that's about 425 feet. Yes? Sea level has risen by 130 meters. When sea level rises by 1 meter, it transgresses by 1 kilometer. General rule of thumb for our kind of, we call it gradient or the slope of the land. 1 is to, so I'll not make it very technical. So for us, our type of land, let's say in Odisha, when the sea level rises by 1 meter, it will transgress, that will invade the land by 1 kilometer. Yes? So sea level has risen by 130 meters. So the sea has invaded by about 100 kilometers. Do you realize that? What is the Odisha's coastline? The length of Odisha's coastline is about 480 kilometers right now. Yes? Present political state that Odisha is has a coastline of about 480 kilometers. By the end of this century, by the end of this 21st century, sea level will definitely rise by 1 meter, very likely by 2 meters. Yes? So if it rises by 2 meters, 480 into 2, that is about 1,000 square kilometers. 1,000 square kilometers of land area of the state of Odisha will be submerged, will be under the sea. Do you realize the problem? Do you think this is a huge problem? This is a huge problem. Now what is the height of Bhubaneswar above sea level? Anybody? Let's say this area. Yes? These are the things you should know. All these won't be taught to you by the school, but this is what you should know. What is the height of this place, let's say, roughly? Anybody? Yes?
30 meters.
Sorry?
30 meters.
30 meters. You are very, very correct, yes. Khandagiri is about, very nice. Cuttack is about 23, all right? Khandagiri is about 45, all right? So 45 meters above sea level, all right? And here I'll tell you something again interesting. I'll go back to that depending on how much time you give me. That all the ice caps, ice sheets and the glaciers that are there on the Earth's surface, if they are to melt, sea level will rise by 80 meters. 80. Yes? So, if it rises by 2 meters in 100 years, how many years will it take to rise by 40 meters? Yes? Yes? How many years? 2000 years, yes? We are talking about rise by 40 meters. 2 meters in 1 century. In 1,000 years, how many? 20 meters. Yes? Say yes loudly. Yes. Good. Then it will take 2,000 years. So in 2,000 years, Bhubaneswar will not be there. In 4,000 years, it will rise by 80 meters. Yes? Now, why is it rising in the first place? Why is it rising? First, because of natural reasons, that is the geological reasons. In geology, we talk about ice ages. The last ice age started something like 100,000 years ago, or about 110,000 years ago. We bring in lots of approximations there. And we say the last ice age ended 15,000 years ago. Some say 10,000 years ago. Why? Why do you say that? Some say 15,000, some say 10,000. Why? Some say because all the ice on the earth have not melted yet. So some say even the ice hasn't completely gone yet. You understand? Because the earth is vast. Yes, it's very large. So we assume it. That's about 15,000 years ago, the last ice age ended. And when ice age ends, all this ice slowly, all these ice sheets, ice caps, glaciers are slowly melting, and that melt water is reaching the sea. Ultimately it has to go to the sea. Yes or no? Ultimately everything has to go to the sea. So the sea level is rising, one. Second is, just like Professor mentioned, always remember, sun is the source of energy and heat for us on planet Earth. Yes? We say solar. What is the meaning of solar? Anybody? Solar is the of the sun, adjective of sun. Global, adjective of globe. Alright? So we say solar radiation, incoming solar radiation. That is the source of energy for us. Yes? Yes? Incoming solar radiation. Can that rise and fall? I'll come to that. Now, when that is coming in, the sea level, sea temperature is rising, yes? When sea temperature rises, that means it has more energy. Think, have you ever boiled water in a pot or in a kettle? Yes or no? Yes. When you raise the temperature, that is, you increase the temperature. These days you have automatic controls, things like that, digital, induction heaters. You raise the temperature, that means you give more energy. What happens to the water in the pot? It boils more vigorously. Yes? Yes. So similarly, if the sea surface temperature rises because of more solar radiation or more intense incoming solar radiation that we call insolation, yes? Sea has more energy. And if sea has more energy, it is more vigorous. When it is more vigorous, there are more cyclones. All right? The science part, Professor has explained very beautifully. So I'm sort of taking it to you. And so it is more vigorous. It starts boiling. In a kettle, you see the water boiling. In sea, of course, you don't see water boiling, but you see the vigorous activities, that is, the cyclones becoming more intense. And when the cyclones become more intense, like we had, he mentioned, we had the super cyclone in 1999, and the wind speed was at least 260 kilometers per hour. The Phylline that you faced in 2013, you all have seen Phylline. You haven't seen the super cyclone of 1919 because you were not born. But you have seen Phylline. What was the temperature? Oh, sorry, what was the wind speed of Phylline? About 180 kilometers. No, it was more. It was about between 215 to 230. Sir, am I right? Yes. 215 to 230 kilometers per hour. All right, Phylline. And he also explained, he mentioned storm surges. When a cyclone hits the land, we call it making landfall. There was wild speculation about Phylline, that where will it make landfall? Where will it enter the landmass? Initially, some people were saying, it will make landfall at Vizag, and then some were saying at Puri, but IMD, Professor Sahu was the director head of the IMD here in Bhubaneswar, and my friend and colleague, we worked together, a gentleman, Dr. L.S. Rathore, he was the DG IMD, Director General of India Meteorological Department. They insisted it will make landfall at Gopalpur and the speed will be 215 to 230. And that proved correct. The American scientists were proved wrong at that time. So President Obama, in fact, asked the Indian administration at that time that do give us some credit. That our scientists, but they were saying wrong things. And when it made landfall at Gopalpur, the Americans were saying that the storm surges would have the height of something like 6 meters. That is because they did not understand the simple thing again the professor mentioned. He mentioned lots of things, but probably you did not understand some of that because you haven't studied meteorology, which you may someday. And this is because of the shallowness or the depth of the sea adjoining the coast. Yes, at Vizag, let's say it is deeper. It's a little less deep at Gopalpur. It is a little lesser deep in Puri, and it becomes even shallower in Paradip, then even shallower in Baleswar and Bangladesh. Now, when that Phylline made landfall at Gopalpur, the storm surge, height of the storm surge was about 2.5 meters. Had the same Phylline made landfall at Puri, probably the height of the storm surge would have been 4 meters. Had that made the same storm, had that made landfall at Paradip, the height probably would have been 6 meters. You understand? That means 6 meter high wave of water, sea water, would have invaded the sea. In Odisha, we say it, Luna Mariase. Alright, that's our Odia word. And that happens. And because of this climate change, or because of the sea is getting more energy, you will get more cyclones. The frequency of cyclones will be more, and the cyclones will be more intense, they will be stronger, and there will be more storm surges. Yes? So that you should become aware of. Alright? Now, if we have, there are lots of interesting things, I'm just picking up the interesting bits. If sea invades the land, lots of people will be rendered homeless. Yes? If it is Puri, the height of Puri is about meter to 2 meters above sea level. Yes? That you all should know. Calcutta, lots of areas in Calcutta are below sea level. Is it possible? Can it really happen? 60% of Holland, have you heard of Holland? Where is it? Where is Holland? In Europe. The other name of Holland is Netherlands. Yes? On the Rhine Delta. 60% of Holland, 60% of the land area of Holland is below sea level. And they have been constructing the dikes for last 700 years. Dikes means large embankments along the sea, on the land, to protect the land from the sea. They have been reclaiming land for the sea for the last 700 years. Now we have to become aware of this. If we do not take any measures, a lot of our land area will be lost to the sea. Say for example, the city of Puri will be submerged. You understand? By the end of this century, there will be no Puri. There will be water on Baradanga. Yes? 100%. If we don't do, in Odisha we don't do anything. What do we do in Odisha? We always say, Jagannatha will take care of us. Jagannatha will not do your work. You have to do your work. When you are not doing your homework, is Jagannath coming helping you? Is he? Because that is your work. Similarly, to protect this land is our work. Alright? Now what will happen to Bangladesh? By the end of this century, I say, let's say if the sea level rises by 2 meters, Odisha will lost about 1,000 square kilometers of land area. Alright? What will happen to Bangladesh? Bangladesh is very low lying and very flat. Yes? About 30% of Bangladesh will be inundated. 30%. What's the population of Bangladesh? Anybody? 180 million, 18 crores, alright? So about a third will lose their homes. Do you see the problem? Population of Odisha? What is the population of Odisha? 4.5 crores, alright? 45 million. Use the word million because million is becoming more popular. What is million? How many zeros after 1? 6 zeros, alright, you know. Odisha population 45 million, alright? Bangladesh about 60 million Bangladeshis will be here looking for asylum in Odisha if we do not take care of the sea level rise. Do you see the problem, the enormity of the problem? Yes or no? So these are huge problems. Now I told you that the ice caps are slowly melting away. This I mentioned that started with the natural process. Alright? On top of that, in 1840s, 1850s, between 1840 and 1860, we say we had industrial revolution. Do you know what that means? Where did it start? Britain. Alright? I'm making it easier for you. Britain it started, industrial revolution. And what's industrial revolution? When machines started replacing men. Alright? Production became mechanized. And how was that possible? Because of steam engine that was invented. Who invented steam engine? James Watt. When? Yes? 1775. Remember that one. 1775 and 1776. What is 1776? What's the importance of 1776? Yes? America, United States became independent. Alright? So 1775, James Watt introduced or invented. He actually invented a little earlier. It was sort of marketed around that time, 1775. And then in 1831, Michael Faraday invented generator. And what is generator? That generates electricity. Yes? So we needed both generator and the steam engine for producing electricity. Yes? Yes or no? Yes. And what was the fuel for these steam engines? Coal. And in 1859, the first oil well was dug in. Anybody knows where the first oil well, petroleum well? In Pennsylvania. Alright, in Pennsylvania, it was dug by a certain Cornell Edwin Drake. That's my geology, my subject, the oil well, in 1859. So petroleum was used. So we started using a lot of coal. We have been using coal, but in a big way we started using coal and petroleum to generate electricity. And then in 1913, a car was mass produced. Can anybody name that car? The first mass produced automobile. Anybody? Sorry? No. The first mass produced car, 1913. From America, yes? Ford, yes? Ford Model T. 15 millions of them were produced. 15 million. Alright? So they started consuming vast quantities of petrol, and today we have millions upon millions of automobiles, and they are consuming petrol and diesel, as you all know, and in the process they are generating a lot of carbon dioxide. Yes? So the carbon dioxide percentage in 1850 was 250 ppm in the atmosphere. What is ppm? Parts per million. You know that one well. All right. So that was 250. And what is the carbon dioxide percentage or carbon dioxide concentration in the atmosphere now, today? Anybody? 400. Actually, I checked on the 20th of September, it was 405. 405 ppm. And carbon dioxide is a greenhouse gas. Professor explained what a greenhouse gas is. It allows incoming short wavelength radiation to come in and does not allow long wave radiation to go out. Traps the heat and the globe gets warmer. So this has started, let's say, with Industrial Revolution, and now it has reached, carbon dioxide has reached 405 ppm in the atmosphere. All right? So now there are, of course, talk of reducing carbon dioxide emissions and reducing the carbon dioxide limits to 350 ppm. All right, it's 4:30. Some of you are leaving. All right, you probably have something. Yes?
No, sir, actually,
all right.
2 weeks, students are 4:31.
All right. So all right, in that case, I'll just go to something. So I touched lots of little things, filing I mentioned. Now I want to say something about tsunamis. All right. Professor also mentioned that a few years ago, there was a massive volcanic eruption in an European country, and that country was Iceland. And Iceland, you might have read it in your geography, that Iceland is the country of, or the land of ice and fire. Snow and fire, yes? So there are thick ice caps, and the ice caps could be 2, 3, 4 kilometers thick. And once they melt away, the pressure on the crust is released, because they are putting a lot of pressure on the crust, on the Earth's crust, on the Earth's surface. So they are keeping the dormant volcanoes dormant. You understand? And once that pressure is released, volcanoes start erupting. So when all the ice caps disappear, there will be a lot of volcanic activity. Yes? And some time back, because of and eventually what will happen? Because of a lot of volcanic activity, there will be a lot of volcanic ashes released into atmosphere, and that will surround the atmosphere, that will surround the globe, and that will stop incoming solar radiation. So the Earth will start cooling again. So this is, Earth goes through periods of glaciation and deglaciation, as we say in geology. All right? And I would be very happy if some of you become students of geology, earth sciences, or atmospheric sciences, or climatology, or oceanography. These are really interesting things. And I was talking to the chairman sir today, your chairman sir today, and I said that I'm very sad to see all these brilliant students going to IITs and becoming engineers and then joining IT companies as clerks. Nowhere else in the world this happens other than in India. Brilliant students, what are you doing? I'm financial analyst for this company. Anybody who gives you a better salary, you run after them. And then why did you study engineering? So I want some of you to study geology, my subject. All right, very fascinating subject, or atmospheric sciences. climatology, oceanography. I want you to produce, from your school, I want to see lovely students studying all these interesting subjects. Now I want to touch on, 4:30 we have to finish, is it? All right, then I won't take much longer. All right, so I just want to tell you a little about desertification. So I talked about the effect on sea, and now the effect on land, so I won't take much time. Desertification, what does that mean? Fication, desertify, fication. What is fication? The process of making a desert, the process of becoming a desert, yes? And what's a desert? A dry land or an arid land that doesn't have water, that means, and also doesn't have much vegetation, yes? Now, what are the big deserts in the world? The biggest one is? Where is Sahara? Which part of Africa? North Africa. Now, do you know that vast quantities of water is being drawn from the depths of Sahara Desert and being transported to Tripoli, the capital of Libya? Do you know this? All right. So how come this is happening? How? Because Sahara was not always a desert. 24,000 years ago, climate changed. The ice caps and glaciers on the mountains there, which is about 2,500 kilometers long chain of mountains, 4.5 kilometer high, not as high as the Himalayas. And what's the name of that mountain chain? Anybody knows? Atlas Mountains. All right, that is Atlas Mountains. That should make sense now to you. Atlas, that's the Atlas Mountains. So the ice caps, glaciers melted away, the rivers dried up, the land became a desert. When rivers die, you understand? When the rivers die, civilizations die. This is based on an interview I gave to Times of India 2 years ago. In Odisha, the rivers are dying. And what are we doing? Nothing. Nothing. We are just happy with our biryani and laptops and mobile and WhatsApp. Mahanadi is dead. I have written to ministries to dredge the river Mahanadi. Now why I am saying that Odisha is becoming a desert. Now I live in Japan. 79% of the land area in Japan is under forest cover. 79%. Actually 69%. And if you add the orchards, that is the fruit gardens, it becomes 79% of the land area is under forest cover. In Odisha, can you make a guess what percentage of land area is under forest cover? 33%. All right, close. 33% of land area is under forest cover. And for the country, what is the average? For our country, for India? 22. Okay, Odisha forest cover is rising slowly. It has reached 33%. But 60 years ago or 70 years ago, it was about 70%. We have cut down the trees, made the mountains barren, and as a result there is no groundwater recharge, and Odisha is becoming a desert. In Japan, I told you 79% of the land area is under forest cover. And what is the population density? Do you think Japan is more densely populated than India, or India is more densely populated? Japan is. Japan is 336 persons per square kilometer of land area. In India, the population density is 334. In Odisha, the population density is 280. Yet, 79% of the land area in Japan is under forest cover. Why? Because the people are responsible, not irresponsible like you are. All right? You are irresponsible. It has become now only 33%. Think how sad it is. And the canopy density is not there. I was talking to, some time back on the 22nd of April, we observe Mother Earth Day. So some 2 years ago, the Ministry of Environment and Forest, or the Department of Environment and Forest of Odisha government, they invited me to give a talk, and I spoke on these aspects. And the Secretary of Environment and Forest, Sri Suresh Chandra Mahapatra, is my student. I taught him like I am trying to teach you, all right? So I taught him when he was a student at Ravenshaw College. He studied geology. He said, sir, 33% is on, he was the secretary. Says, sir, 33% only on paper. The canopy density is not there. You understand? If this is the forest and it should have 50 trees, Odisha probably has only 30 trees or 23. The canopy density is not there. Yes, what is the canopy? The top part. The foliage, total foliage of a tree. The canopy density is not there. And see how very sad this is. So here is your responsibility. And how do you make Odisha green again? It is necessary that we fight desertification. How can we do it? Can it be done at all? Yes. All these are problems and there are solutions. It's not that we have to invent the solutions. The solutions are there. Like I told you, when the sea level is rising and we have to protect the land, we have to do what the Dutch have been doing for the last 700 years. They have been constructing their dikes. Yes? We should start working on constructing dikes. Now for desertification, how do we combat it? By? No. Go back to Chandogya Upanishad. What did I say? Essence of planet Earth is? Water. Essence of water is? Plant. If you make arrangement for water, plants will grow automatically. But here we are doing the other way around. We are planting the plants first and then trying to put water. No, don't do it. Construct tens of thousands of micro dams. Japan does not have a single large dam. They have tens of thousands of micro dams. Micro dams are anywhere between 1 meter and 10 meters high. They're like, in our Odia, like headers. They don't create reservoirs. They merely arrest the flow of water, impound some water, the excess flows over it. Yes? And whatever is arrested recharges groundwater. Like you see, if you have a pile of sand and you pour a bucket of water to that pile of sand, where does it go? It disappears. It disappears into the pore spaces, that is grain interstices, the little spaces between the grains. Similarly, we call that porosity. That's my subject again, groundwater. So groundwater stays in the porosity. And however solid the mountains may look, the porosity is anywhere between 20 and 50%. Remember, mountains, they look solid, but they are empty. So once the mountain porosity is filled with groundwater, then the rivers become perennial. Professor mentioned perennial rivers when they are running round the year. The rivers that are not perennial, what do we call them? Short-lived rivers? Sorry? No. Anything else? Ephemeral. Short-lived. Alright? Seasonal, you can say alright. So these are perennial rivers. And that is the reason why, again, I take you back to our Hindu scriptures. In Hinduism, Hindu scriptures, mountains are always the fathers of the rivers. Yes? Himalaya is the father of Ganga, Jamuna, Saraswati, Brahmaputra, Indus, everything. And in Odisha we have a river called Mahendra Tanaya. Anybody? Mahendra Tanaya, daughter of Mahendra Parvata, of course. Yes? So, why is it the father of rivers? Because this stores water. And you can calculate the total mountain area and the porosity there, and you will find it is in billions of cubic meters, much bigger than Hirakud Dam in Odisha. So if we can store water in the mountains, and how can we do it? By constructing tens of thousands of micro dams right from the top of the mountain as the streams descend. So I have been persisting with this, and Odisha government, I have an article called Eastern India Must Not Become a Desert. You can do a Google search, Dr. Nachiyata Das, and you will see all these things. And in 2010, Chief Minister took a meeting of Suresh Mahapatra. He was the Secretary of Water Resources, etc., etc. They decided to construct microdams in Odisha. And as of today, they have constructed 8,000 microdams. And now they are constructing at the rate of 4,000 microdams per year. I'm saying 4,000 is not enough. Construct at the rate of 10,000 and complete 50,000 in the next 5 years so that Odisha can become green again. All right? So now you know, if you construct microdams, if you fill up the porosity of the mountains with water, and then trees will grow automatically. You don't have to plant a single tree. They will grow automatically. All right? The birds will drop the seeds and they will grow. All right? So, all right. And has this been done somewhere? Have we combated desertification somewhere? Have we revived the river somewhere, anywhere in India, in Odisha? In Rajasthan, Alwar district, a certain Rajendra Singh and his Sangha, they constructed lots of microdams. And they revived rivers that were dead for 50 years. In Nayagarh district, Professor Narayan Hajari, he revived the forests and the ground water level came up very significantly. Nana Hazare has done this in Gujarat, Maharashtra, and we have to do this in Odisha. All right, so these are some of these effects of climate change, and these are some of the methods you can combat the adverse effects of climate change. Thank you for listening to me. Was it interesting?
Yes.
All right. Good, thank you. Thank you very much.
Thank you, sir.